China is sinking some of its most powerful computers to the bottom of the ocean. Not next to the ocean, not near the ocean, actually underwater. And the reason has almost nothing to do with water. In fact, by the end of this video, you'll see why some experts believe this project could be connected to a problem that may determine the future of artificial intelligence itself. A problem so serious that companies are spending hundreds of billions of dollars trying to solve it. And if China is right, the solution may already be sitting on the ocean floor.
Let's be honest. The idea sounds ridiculous. Computers and water don't exactly have a great track record. Most people panic when they spill a glass of water near a laptop. China looked at that problem and apparently thought, what if we put an entire data center underwater? And somehow, they weren't joking. Off the coast of China, massive steel capsules filled with powerful servers now sit beneath the ocean, running day and night, processing enormous amounts of data, supporting artificial intelligence workloads, helping power the digital economy. Now, here's the question. Why? Why would anyone spend millions of dollars placing sensitive electronics in one of the harshest environments on Earth? Salt water destroys metal. Ocean pressure is intense. Maintenance becomes incredibly difficult. Everything about this seems like a terrible idea. And yet China built it anyway. Which means one of two things is true. Either this is one of the most expensive engineering mistakes in history, or they're solving a problem the rest of the world hasn't fully recognized yet. And that's where things get interesting. Because this story isn't really about underwater computers. It's about a much bigger question. A question almost nobody is asking. What if artificial intelligence is about to hit a wall? Not because AI is getting less intelligent, but because the world may struggle to support the infrastructure AI requires. Keep that thought in mind, because it becomes incredibly important later. First, we need to see what China actually built.
Imagine standing on a boat in the South China Sea. The water looks completely normal. Nothing unusual, nothing futuristic, nothing that would suggest one of the strangest technology projects on Earth is sitting directly beneath you. But hundreds of feet below the surface is a giant steel capsule, over 1,000 tons, packed with servers, processors, networking equipment, storage systems, all operating underwater. Think about how unusual that is. For decades, data centers have looked pretty much the same. Large buildings, rows of servers, massive cooling systems, huge electrical infrastructure. China looked at that model and decided to try something completely different. And here's the crazy part. This isn't a science experiment. It's real infrastructure. Infrastructure intended to support AI applications, cloud computing, industrial systems, and digital services. The kind of systems that power modern economies. Now, let's pause for a second. Because if you're wondering, how do they fix something if it breaks? You're asking exactly the right question. Imagine a server fails. You can't simply walk into the room and replace it. You can't call the IT department. You can't swap out a cable. Everything must be designed differently. Everything must be engineered for extreme reliability. And that's exactly what makes this project so fascinating. Because engineers knowingly accepted all those challenges, which means there must be a benefit big enough to justify them. A benefit worth millions of dollars, maybe billions. And what researchers discovered years earlier may provide the first clue. At this point, the project already sounds risky enough. But what engineers discovered after testing underwater servers shocked many experts.
In fact, one unexpected result completely changed how people viewed underwater computing. We'll get there in a moment. But first, we need to understand why the world suddenly needs so much computing power in the first place. And trust me, the numbers are much bigger than most people realize. A few years ago, most people barely thought about artificial intelligence. Today, it's everywhere. Chatbots, image generators, video creation tools, code assistants, virtual agents. Every month seems to bring another breakthrough. And behind every one of those breakthroughs is something most people never see: data centers. Lots of them. When you ask an AI a question, thousands of processors may work together to generate a response. Now multiply that by millions of users, then billions. The scale becomes almost impossible to comprehend. Here's a shocking statistic. Some estimates suggest future AI infrastructure investments could exceed hundreds of billions of dollars annually. That's not spending on apps. That's spending on the physical infrastructure needed to support AI. The buildings, the processors, the power systems, the cooling systems, everything. And the demand keeps growing. Every new AI model requires more computing power, more servers, more electricity, more infrastructure. Which raises a fascinating question. What happens if AI demand grows faster than our ability to build the infrastructure supporting it? Because that's exactly what some experts are beginning to worry about. And if they're right, the biggest challenge facing AI may have nothing to do with intelligence.
Most people think the future of AI depends on smarter software. But what if the real battle is happening somewhere else? What if the future of AI depends on solving an infrastructure problem so massive that entire countries are searching for answers? And what if China's underwater project is one of those answers? Before we can understand that possibility, we need to go to Scotland, because that's where this story really begins. Several years ago, Microsoft decided to test an idea that sounded completely absurd. Take a data center, seal it inside a giant metal container, drop it into the ocean, and leave it there. The project became known as Project Natick. At the time, many people thought it was a publicity stunt. Others assumed it would fail. After all, placing expensive computers underwater sounds like the exact opposite of what engineers should do. But Microsoft moved forward anyway. The company lowered a data center off the coast of Scotland. Then they waited. Months passed. Then years. Eventually, researchers analyzed the results, and what they discovered surprised everyone. The underwater systems experienced fewer hardware failures than many traditional data centers. Think about that. The environment everyone assumed would be dangerous for computers actually produced some surprisingly positive results. Why? Because sealed underwater environments eliminate some problems common in conventional facilities. Fewer people interacting with equipment, stable environmental conditions, controlled operating environments. And suddenly, the impossible didn't seem so impossible anymore. Governments noticed, technology companies noticed, and eventually, China noticed. But here's the thing. Lower failure rates weren't the biggest discovery. Not even close. There was another benefit hiding beneath the surface. A benefit that may explain why China decided to scale the idea much further. When Microsoft reviewed the results, engineers realized they might be looking at more than an interesting experiment. They might be looking at a solution to a much larger problem. A problem becoming more serious every year. And strangely enough, that problem isn't computing power. It's what happens after the computing power is used. Let's do a quick experiment. Imagine turning on a powerful gaming PC. Now imagine turning on 10,000 of them. Now imagine turning on 100,000. What happens? Heat. An unbelievable amount of heat. Every processor generates heat. Every graphics chip generates heat. Every AI accelerator generates heat. And modern AI systems contain thousands upon thousands of these components. Here's a fact that surprises many people. Some modern data centers spend a massive portion of their energy budget simply keeping equipment cool. Not computing, not processing data, cooling. Think about that. Companies are spending billions of dollars building facilities whose primary purpose is preventing computers from overheating. And as AI grows, that challenge becomes even bigger. Because the more powerful AI becomes, the more heat it generates. Now, you might think we've solved the mystery. Computers get hot, the ocean is cold. Case closed. Not even close. Because if cooling was the only goal, there were easier ways to achieve it. Much easier. So why spend millions putting servers beneath the ocean floor? That's the real question. And we're going to uncover something most people never hear about. A hidden crisis involving electricity, infrastructure, land, and AI growth. A crisis that may explain why some experts believe artificial intelligence is heading toward a bottleneck. And if that bottleneck isn't solved, it could change the future of AI itself. At this point, we've uncovered part of the mystery. China is building underwater data centers. Microsoft proved the concept could work. And cooling appears to be an important piece of the puzzle. But we're still missing something. A very important question. Why now? Why are governments and technology companies suddenly interested in ideas that would have sounded ridiculous 10 years ago? The answer starts with a problem most people never see. Because while the world is focused on smarter AI, engineers are becoming increasingly concerned about something else. Whether we can actually support it. Think about what has happened over the last few years. AI went from a niche technology to one of the biggest industries on Earth. Companies are spending hundreds of billions of dollars. Entire nations are developing AI strategies. Investors are pouring money into anything remotely connected to artificial intelligence. Everyone wants more AI. But very few people are asking an uncomfortable question. What happens if demand grows faster than infrastructure? Because that's exactly what some experts believe may be starting to happen. And nowhere is that problem more visible than inside the world's largest data centers.
At first, that sounds impossible. How can we run out of infrastructure? Can't we just build more? The answer is yes, but it's not nearly as simple as it sounds. Because modern AI facilities require something that is becoming increasingly difficult to find. And it's not computer chips.
Let's talk about land. Not exactly the most exciting topic, but it might become one of the most important resources in the AI era. Modern AI data centers are enormous. Some facilities cover hundreds of acres. Others are so large they resemble industrial cities. And they can't be built just anywhere. They need access to major power infrastructure, fiber optic networks, transportation systems, water resources, engineering support. The list goes on and on. Now, imagine every major technology company trying to build more facilities at the same time. Suddenly, competition becomes intense. The best locations disappear quickly. Prices rise. Projects become delayed. Infrastructure gets stretched. And here's something many people don't realize. Building a new large-scale data center can take years, sometimes many years, which means AI demand can grow much faster than infrastructure can be deployed. Now, remember China's underwater project? The ocean doesn't have many of those limitations. There's no competing housing development.
No office park, no shopping mall, no bidding war over land. Just enormous amounts of available space.
suddenly putting infrastructure offshore starts sounding less crazy. But land isn't the biggest issue. Not even close. The real challenge is power, and the numbers are astonishing. At this point, China appears to be solving multiple problems at once: space, cooling, infrastructure. But none of those are what really caught experts' attention. The real reason may be connected to a number so large it sounds almost unbelievable, a number that could reshape the future of AI. Imagine a city with hundreds of thousands of homes. Now imagine all of those homes consuming electricity at the same time. That's roughly the scale some future AI facilities may require. Read that again. Some projections suggest future AI campuses could consume amounts of power comparable to small cities. And that's where things start getting serious. Because AI isn't just software. It's electricity transformed into intelligence. Every AI response, every generated image, every video, every calculation, every prediction requires energy, massive amounts of it. And demand is accelerating. Some analysts believe global AI infrastructure investment could eventually reach levels that rival some of the largest industrial expansions in modern history. Think about how crazy that is. For decades, the internet changed the world. Now we're building an entirely new layer on top of it. And that layer is incredibly power hungry, which creates a new problem. What happens when everyone wants more computing power than the grid can provide? Because some regions are already asking that question, and the answer isn't entirely clear. And now, AI is creating a new infrastructure challenge, one that may reshape computing over the next several decades. Maybe underwater data centers become common. Maybe they remain rare. Maybe future AI systems operate from giant facilities beneath the ocean. Or maybe an entirely different solution emerges. We don't know. But here's what we do know. The companies and countries that solve AI's infrastructure problems will have a significant advantage. And China appears determined to be one of them. Which means this story was never really about underwater computers. It was about what comes next. Because the next great breakthrough in AI may not come from a laboratory. It may not come from a new algorithm. It may not come from a more powerful chip. It may come from solving a problem as old as computing itself: heat. And if China is right, the solution may already be sitting quietly on the ocean floor, waiting, while the rest of the world catches up. If you enjoyed this deep dive into the future of technology, don't forget to like the video, subscribe to the channel, and turn on notifications for more stories shaping tomorrow. Thanks for watching, and I'll see you in the next one.